Hi, everybody. I'll start now. We'll be talking about vector tiles generated by GeoServer and rendered using OpenLayers. Others might disagree, but vector tiles, for me, are the most interesting thing to happen to GeoServer in quite a while. They're really easy to use, and they open up a lot of possibilities. I'm really excited to talk to you guys about it. Here's our cast of characters. Gabriel, unfortunately, he's not here. He sends his regrets. He wrote the GeoServer vector tiles components. Andreas, he's here. He wrote the OpenLayers components. He's going to talking about OpenLayers in a little bit. I'm David. I integrated vector tiles into Boundless Suite, which includes GeoServer. And I'm currently moving the vector tiles from a GeoServer community module into a GeoServer extension, which makes them a little more official. And I'll likely be the module maintainer. We're here from Boundless. Just to note, we're hiring, so come talk to us after. Let's get started. I just want to quickly introduce vector tiles in relation to what's familiar to you, tile maps. Here's a standard web map, open street map. We all use them. You pan around, you see little independent square images called tiles get pulled in from the server. These maps are great. The server only has to draw each tile once. It's cached, and then it's very quick for everyone using the map. They make for fabulously interactive maps. Here's a OSM tile. A lot of time and effort went into the cartography for this. It's really clear. It's great. It's beautiful. Super easy to put a map together using these. But there's not much I can do with it other than draw it. I'm not getting access to the underlying featured line work. I don't have any control over how the map looks. It's set in stone. So what if I do the hard work of the data prep, finding out what's at each zoom level, get ready to draw, but I don't actually draw it. Instead, I package the features into squares, just waiting to be drawn. Call these data tiles, without any styling or without any styling information, vector tiles. Just to be clear, I'm showing a graphical representation, but there's no styling information in vector tiles. We take the vector tiles, put them in a grid, and cache them. We then deliver them exactly the same way as the image tile maps, except instead of just blitting the information on the screen, the client decides what's drawn and how the map looks. It does the rendering. The end result is a personalized, interactive vector tiles web map. I want to emphasize that image tile maps and vector tile maps are very similar, except for image tile maps use pre-generated images on the server, and vector tiles are rendered on the client in the browser. Other than that, they're pretty much identical. I just want to do some comparisons between vector and image tiles. Vector tiles are really empowering and efficient, but they're a little bit harder to work with. There's 1,000 stories you want to tell with your map data. Vector tiles empowers the client instead of the server to decide which story is told, because the client decides on what the map looks like. You're not constrained to the server's cartography decisions. They're also really efficient because you can tell all your 1,000 stories with the exact same vector tiles. You only need one copy of them on the server, not one for each map, just one copy, and just style differently on the client. They're also really efficient because you can really pack a lot of information to a little space. This is especially true for high-resolution screens that are popular nowadays. You have to bring in a lot of pixels, and that means a lot of image tiles. That's tons of extra server bandwidth and storage. Drawing vectors, which look good at any resolution, instead of pre-generated images, can be really efficient. It's a huge savings. Image tiles are one-size-fits-all, makes them really easy to use. You're just blitting images on the screen. With vector tiles, you have to know your data and how to create the styling for it. That's more work. There's also more to know to use vectors and style them. Luckily, Andreas here has done all the hard work involved to make them really easy to use, and he'll be going through that later. I've introduced vector tiles, so we'll tell you what Andreas and I will be talking about. I'm going to be talking more about the server side, GeoServer to create the actual vector tiles, and touching a little bit on Geo Web Cache, which handles tiling and caching, and mostly just magically works for you. I'll be showing it only takes about 5 seconds to get your data into vector tiles using GeoServer. Really easy. and a little bit of how Vector Tiles fits in the OGC web services context. I'll go into detail about the GeoServer rendering process, which is important to know so you understand what's happening with your data while it goes to the client. And I'll show you how to use SLD to control vector tile generation. Andreas will be talking about and demoing the client side, OpenLayers. He'll be introducing OpenLayers, talking about how to create a vector tiles map, styling it, showing some advanced user interactions, and a slick demo. It's super easy to get vector tiles from GeoServer and Geo Web Cache. Instead of asking for an image, like a PNG, from GeoServer's WMS, just ask for it in a vector tile format. That's it. MapBox, GeoJSON, or TopoJSON are the currently supported ones. Instead of drawing onto an image canvas, GeoServer draws onto a featured data format file. And I'll go into this in detail in a little bit. And to make them available through Geo Web Cache, to do tiling and caching, just tick the box on the vector tile format you're publishing to, and it does the rest. That's it. 5 seconds and you're cooking with gas. Before I go into some more details, I just want to put vector tiles in the context of the OGC services. It's a little confusing because if you think vector tiles, you're thinking making maps with them. So I'm thinking WMS. There's also tiles in the title, so I'm thinking tiling services like WMTS. And there's also vectors in the tile, so I'm thinking WFS, which is about querying and retrieving features. It's all a little bit confusing. So just to be clear, we use GeoServer's WMS with a special vector tiles renderer to generate tiles. We use Geo Web Cache to handle the caching and tiling, and Geo Web Cache is just magical, it just works. And WFS, in the context of vector tiles, it's surprisingly pretty much independent. I'll talk a little bit about that. A lot of people feel that because WFS is about access to unstyled feature data, there should be a connection between vector tiles and WFS. Turns out that although both do provide access to feature data, geometry, and attributes, they differ because vector tiles provide easy to render features, and WFS returns the glorious feature detail that you need for actual GIS analysis. One of the first questions I had when I first learned about vector tiles is why couldn't I just use the WFS as is? It turns out it's really inefficient and impractical and just wouldn't work. That's because WFS has always returned the full geometry. We certainly wouldn't want every tile, and there could be millions, to have a 4 million point polygon in it, like I'm showing here. We certainly don't want every tile to have them in it. That's why we don't use the WFS. Instead, we use a custom WMS renderer, and I'm going to look at it in detail to explain how features are rendered into vector tiles. So GeoServer's WMS rendering process is fairly comprehensive, and there's two main renderers. There's the streaming renderer used to make image maps, draw styles features onto an image. There's the vector tiles renderer used to make vector tiles. It draws unstyled features into a data file. In the end, both renderers are pretty similar. They both pre-process and render the data either onto an image or into a data file. The steps are important. We're going to look at how the features in the client I'll go through a little bit of the details of how the renderer actually goes through the process, taking features from your base data out to the client. Generalization. Using less points to represent the features in a manner that doesn't make it visually different. This really cuts down the size of the vector tiles. It means a lot less storage, bandwidth, and rendering time, so it's important. It doesn't affect how the features look. As you can see, one of them has a lot less points in it than the other. It's smaller and quicker to render, and GeoServer creates this automatically when you're zoomed out. I put the slide in because you're going to notice that your vector tiles are sometimes missing some very small features. GeoServer tries to optimize rendering when you're drawing large numbers of very small, about a pixel in size features. Basically, if it's already drawn a feature into a pixel, it doesn't continue drawing tiny features on top of that pixel. It's not going to change what the map looks like. Example here from OpenStreetMap. On the blue, it's California, and it's 1.2 million features. Most of these features at this scale are less than a pixel in size. There's no need to draw them all. And in fact, if you were to request this tile, you'll get about 175,000 of those 1.2 million features. It's a big savings, and the map looks the same. A more likely example is the motorways in red, which has 18,000 features, but only draw about 7,000 of them. Again, big savings, and the map looks the same. I'm just pointing this out because it's a gotcha if you're not paying attention. It's also an indication that you could pre-process your data a little more effectively. Clipping. We clip so we're only sending what's needed to draw the tile, saving bandwidth, storage, and rendering time. But we don't clip right at the tile boundary. If we did, the tile would look wrong at the edges, especially if you're using thick or big styles where features cross or near tile boundaries. In fact, I just fixed a clipping too close issue, and as you can see at the top, it looks pretty horrible if you clip right at the tile boundaries. One of the side effects of this is that you'll see the overlapping data in adjacent tiles, which isn't a problem when rendering, but it can be something to be aware of if you're trying to do any analysis. An OpenLayers note is OpenLayers draws all the data in the tile, but the rendering is clipped to the exact tile boundary. This is exactly what you want, and you get good maps out of it. The final piece of the puzzle is how do we decide what data is in the tiles at various map scales. For example, when zoomed out, I only want to show highways. When zoomed in, I want to show most of the roads. In comes SLD, Style Layer Descriptor, which is the standard OGC way to describe how to style a map. SLD is usually associated with making pretty maps, colors, fills, and thick lines, things like that. Styling is the job of the streaming renderer for drawing images. The vectors tiles renderer is simpler. If the SLD rule would have drawn a feature on the image, it draws it without styling information onto the vector tiles data file. It's as simple as that. If your SLD would have drawn the feature onto an image, it'll be in your vector tiles data. And there's three parts to an SLD rule, and I'll give an example in a second. Scale, how zoomed in and out you are determines if the rule gets turned on or off. It has a filter, so you can tell which data you're actually that rule is firing on, and styling, which isn't something you use with vector tiles. Now, I made a really ugly map, and you could if you tried harder, you could probably make it uglier. But I'm going to just spend a little bit of time on a concrete example of how to use SLD to generate your vector tiles. You can see a basic SLD rule for showing residential roads using a data filter when you're zoomed into more than 1 to 70,000. The streaming renderer would be showing thin blue lines when you're zoomed in more than 1 to 70,000. The vector tile renderer with the same SLD, you would get the features will get put into the vector tiles data file with no styling when you're zoomed in more than 1 to 70,000. And just remember, when the streaming renderer would have drawn the feature, the vector tiles renderer puts it in the data file. And I'm purposely using a really ugly map here just to make a point, is with vector tiles, you don't have to go with my sense of cartography and styling. You get to do it yourself. So a big advantage. So using Geo Web Cache to tile and cache your WMS images using this SLD, and boom, you've got a really ugly web map that shows different levels of detail depending on zoomed in you are. But if you wanted to use my data but not my colors and stylings, how would I enable that, and how would you use that? Click, that's it. Just 5 seconds to make this available as vector tiles in Geo Web Cache. And we empower the client, that's you guys, to make all the styling decisions. And now we're cooking with gas. Really simple. Here's an example of an image and vector tiles map. I put the same styling on both maps. As you expect, they look and behave pretty much exactly the same. There are two types of common changes I want to show you. First involves just changing how the client map looks, styling. Second involves changing the server's SLD to change the data that gets put into the vector tiles. The first is really simple. Style change is shown here. This is where vector tiles really shine. If you want your map to look different, you just have to change the client styling function. Andreas is going to talk about that. and nothing on the server changes. You don't have to regenerate any tiles. I updated the OpenLayers styling function here to do road casing. As you can see, I don't have to change anything on the server. I just keep using the exact same tiles, and now I have two different looking maps. The second type of change is more complicated. My map is missing some of the features I want to draw. They're just not there in the files, in the vector tiles. The SLD isn't putting OSM footways into the vector tiles because there's no SLD rule that says to do that. To add this data in the vector tile, I update the SLD and add a rule so that it renders the footways into the vector tiles. Geo Web Cache will magically notice the SLD change and reset your cache. This is an example of a change on the server to change the content of the vector tiles data. The previous was a client change to change the styling of the map. And now I've added the footways to the vector tile data. I can update my OpenLayers style so it shows them. I've chosen pink dashed lines to go with my world's eggless map theme. And this is behind the basic idea behind vector tiles and GeoServer. We use SLD to render features, including generalization and clipping, into data files that Geo Web Cache makes available in a cached and tiled manner. It's really easy. And Andreas is going to talk to us about OpenLayers.
Few seconds to get the recording right. Okay, OpenLayers. For those of you who don't know OpenLayers, OpenLayers is a mapping library that allows you to map pretty much everything. You can map images, those could be static images or images created by an image service like WMS. You can render image tiles like the ones you get from commercial map providers like Bing or Here, or free ones like OpenStreetMap, basically anything that is organized in a tile grid. You can render vector data in all common formats like GeoJSON, KML, GPX. And what's quite new since last fall is you can render tile vector data. And this is what we're going to focus on today. A few more interesting features of OpenLayers: you can use any projection. If your base map is not available in the projection that you'd like to use, just throw it at OpenLayers and it will reproject it on the fly. So you could do OpenStreetMap base map in a local projection that you'd prefer to use. Another nice feature is you can use any orientation and you can rotate your map. Just think you want to do a navigation system with OpenLayers where you want a head-up view instead of a north-up view, or you want to do indoor mapping where north-up may not be appropriate. In addition to that, you can animate your view. You can either animate the way you look at the map, change the zoom and the center of your map dynamically and create an animation with that, or you can create custom animations based on features, or if you want to show moving objects, you can animate those as well. And finally, OpenLayers integrates well with third-party libraries, like, for example, Cesium, which allows you to create 3D maps on a globe, or D3 to create data-driven views of geospatial data. Generally speaking, if it has location, then there's probably a way for OpenLayers to render it. Vector tiles in OpenLayers is what we're going to focus on today. The preferred format is MapBox Vector Tiles. I'm going to talk a bit more about this in the next slide, because they are optimized for rendering, and OpenLayers can take advantage of that. But in general, all vector formats are supported. There are some vector tiles available on the web that use GeoJSON or TopoJSON as format. You can use those as well. An important thing is you can use the same styling framework that you would use for untiled vector data, using style functions where you can style based on attributes and zoom or resolution that you're looking at. And you can also create interactive maps like you could with vector data. You have access to the feature attributes that come with the vector tile, and you can query the features at your current pointer position or at any pixel or coordinate on your map. And I want to mention this again because it's often confused. Vector tiles are really not meant as a replacement for vector as in WFS data. So if you wanted to edit your geometries, do spatial analysis, select features, that's not what they're meant for. MapBox Vector Tiles are supported through the OL format MVT class. That class uses MapBox's PBF library internally to read the protobuffer, the binary data that's used for these vector tiles. And on top of that, we use MapBox's vector tile library to extract the layers, features, and geometries from the vector tiles. And it is also configurable to only read a subset of the available layers. What Dave showed, you can create a group layer in GeoServer that includes many layers. You will have access to the names of these layers in the vector tiles, and if you're not interested in some of these layers, you can just exclude them from parsing by configuring the MVT format accordingly. By default, for MapBox Vector Tiles, OpenLayers creates a lightweight flavor of the feature, which is called OL render feature, instead of a plain OL feature. The reason is some of the optimizations that Dave outlined also happen on the client in OpenLayers, like remove points that would not make the map look different, and other optimizations that you don't need for vector tiles because these have already been made. So we use the lightweight OL render feature instead by default. It still gives you access to the feature information, as you will see later in the demo. Now, how do I connect to a vector tile layer that was created with GeoServer and Geo Web Cache? There are different ways to do it. An easy one that Dave likes in particular is to use the WMTS format. It's easy to send a WMTS get capabilities request to GeoServer. In that response, you get metadata for all the layers that are available. And with that metadata, you can use the options from capabilities function of OpenLayers to create a WMTS source configuration. All you have to know is the layer you want to render, which in our case is the OpenGeo California layer. You have to know the metric set you're going to use. That's usually tied to the projection you're using. In this case, is Web Mercator, and the format you're interested in. The same WMTS could provide image tiles in PNG format, but what we want is MapBox Vector Tiles in the protobuf format. Once you have this source created from the options from the capabilities document, you go ahead and create an OL layer vector tile with an OL source vector tile. So the WMTS source that we have created in the previous step is made for rendering images, so we're not going to use it directly. Instead, we borrow its tile URL function. That is the function that determines the exact URL for each tile coordinate, and we borrow the tile grid configuration. This is how the tiles are set up at the different resolutions. If you know you're going to use the standard tile grid for Web Mercator and you know your layer name already and the URL, you can skip that WMTS step and just create the OL source vector tile with a URL. Instead of the tile URL function, there you can use the X, Y, and Z placeholders for the tile coordinate. And you don't even need to configure a tile grid then, because the default tile grid is going to work fine. And the last line here in this code snippet is the most important one. This is where we go into styling. And as already mentioned, styling in OpenLayers works by providing a function that takes a feature and the resolution as arguments. And with that, you can do attribute-based and resolution-based styling like you could do with SLD on the server side. For the road casing that we already saw in a previous slide, you would create two styles, two symbolizers that get rendered on top of each other. And OpenLayers also has Z-index support to make sure that the outline of the road is always rendered underneath the thinner line that you use for the fill of the road. Otherwise, you get artifacts at intersections, for example. So this gives you very nice road styles. We're going to look more at the styles as we go into the demo later. We can also add interactivity to our map. For example, we want an info box as we hover over our map that shows the name of the street that we're looking at. For that, we use an OL overlay. That's basically just an HTML element that is anchored to a geographic location on our map. And we configure a listener to pointer move. So when we move our pointer on the map, we get the pixel that we're looking at, and then we query the map for each feature at that pixel. And for the first returned feature, we extract the name attribute of that feature, and we're going to render the name of that feature in the HTML element that we have in this anchored overlay. Okay, so give me a second to switch laptops for our live demo, and then I'm going to show you this all in action. Okay, let's start with the, as Dave calls it, the ugliest map, or well, you could create an uglier map, but that was the first iteration that Dave made when he played with vector tiles in OpenLayers. Still a map that you can navigate and everything you would expect from a map. In the second iteration, Dave added this road casing. As you can see, also the intersections look nice because we were using the Z-index properly. And then I took the same data set and spent a bit more time on the styling to come up with a map like this. So as you can see, the style changes with the resolution. So when I zoom out, the roads get thinner to see more from the land layer, this coastline here. A bit more about the data maybe. We have two layers here in the group layer in OpenLayers. One is the land with the coastlines. It's a shapefile of several hundred megabytes. And then the roads and streets, that's I think 400 or 500 megabytes of data. And that's all processed by GeoServer into these vector tiles. And this is also why you get decent performance. Another thing to note here in OpenLayers, as I zoom in again, tiles from previous, from lower resolutions that are already available are rendered until the tile for the higher resolution is loading. This also works if you pan the map. So if you've looked at a section of the map at a lower resolution already, these tiles are used so you never fall off the edge of the map as you pan around. You can see here that we're first seeing lower resolutions and then the vector tiles for the higher resolutions that we look at get loaded. Okay, so Dave already mentioned that you can tell different stories with the same data. You can tell those stories even without reloading any data. I'm just going to change the style here programmatically. And when I do that, we don't even reload anything. We just really change the style. So give me a second to type this here. So what I did here is I saved the style that we currently have for later. And now I'm going to assign a new style. I'm going to set the style on the layer to the default style of that OpenLayers uses for vector data, which is a bit ugly, but just to show you, without reloading any data, I get a completely different map with the same data. And here you can also see that the land cover, the tile borders are rendered here because they have an outline for these split polygons. Usually I don't render the outline for these polygons, and then I get a smooth land cover layer. And if I'm sick of this default style, I just switch back to the style that I've saved before. And that's it. All right. Bit more on this. What I've shown here is still the geographic coordinates projection. This is why when you look here at San Francisco, for example, it looks a bit unfamiliar. The blocks are a bit squeezed. So I can do the exact same thing in Web Mercator. I just request a different tile set from the server. And here I've also added some interactivity. So as you can see, for those roads that have attribute information available, if I hover over them, they get displayed in this info box here. A bit more about the styling maybe. Let me show you the style function that I used to create this map. So it starts with the function signature. So the function is called for styling every feature with the feature and the resolution as arguments. And from the feature, I can extract properties. The layer from the original layer in GeoServer is available as the layer property. So for the land polygon, North America's polygon, I just return a polygon style that I have created. And then for features that are on the roads layer, I go into more detail. I determine the type of the road by extracting the type attribute from the feature. And then depending on what type of road or street it is, I apply different styles. And I have 2 line styles prepared here for very small paths, footways, and cycleways. I just use a single line where, depending on what it is, I can also set line dash for. And those go on a very low z-index because higher level roads should cover these paths. And then as the streets or roads get more important, I use a different prepared style, the complex line, which is like the one I showed in the slide, consists of 2 symbolizers with different stroke width to get this road casing look of the style. Okay, one thing that we don't have on this map, because we didn't include any points of interest or other data here, which we could have done. I'm just going to show you one of the official examples from OpenLayers, and this renders MapBox provided tile set, and here we also have labels and everything. And I could zoom here to North Carolina maybe. And this is how a map with labels look. One more thing that you can see as I zoom in and out, the labels stay on the screen, so this is nice rendering. And I can also rotate the map. And you see as I rotate the map, the labels remain upright. Okay, time's up. Thanks for paying attention, and we're still here to answer questions if there are any. Thank you.
Can you take advantage of OpenLayers compositing abilities for styles?
Question is if we can take advantage of OpenLayers compositing capabilities for styles. I'm not sure what you mean exactly. Do you mean that you can get access to the canvas when every frame is rendered, or what exactly are you referring to?
I don't know. I just know there's a blend mode
Oh, the blend mode. Yeah. You can do this with any type of data. So the way rendering works in OpenLayers is each layer gets rendered separately, and the layers get composed into a final rendered image. So you could also create a snapshot of this image, and you can intercept the rendering of a single layer or of the whole map. And blend modes in Canvas means that you can influence the function that's used internally by the GPU or by the Canvas engine to add rendered pixels on top of other rendered pixels. And with this, you can make the map look completely different. This also allows you to create masks or something using a polygon. And yes, you can do this with Vector Tiles too, because it works exactly the same way as for all other layer types. Other question?
Do you support overview with the vector tile? So, especially if you're offline, so you generate tiles to 16 and you need to do to 80, you kind of show something similar.
So I think the question is whether we can also render the maps offline. Is this correct?
Yeah, but specifically, can you just have a level 16 tile and zoom into level 80?
All right, so the question is about reusing zoom levels if you have low bandwidth or you don't have all zoom levels available. That's possible indeed. So, and that's also a nice thing about the nature of vector tiles. If you render them at a higher resolution, they will still be rendered very crisp because you render the vectors with the original pixels and with the original style. There's only one thing you have to keep in mind. By default, OpenLayers uses a hybrid mode for rendering, so polygons and lines are stored in pre-rendered images, but you can change the render mode to vector, and then everything is rendered as vectors at another resolution. We have an example that does exactly this. So for this MapBox Vector Tiles advanced example, we don't request the tiles for each resolution. I think we skip every other zoom level and the map still looks more or less the same, as you can see. I think we have time for one more question here.
How about other mapping components such as labeling and also like locating, searching capability or printing? And does this library have those modules?
A question about general mapping components in OpenLayers, like printing maps or search capabilities. What was the first one? Labeling, right. So labeling is part of the rendering process. So here you can see static labels. In my demo, I showed dynamic labeling in an info tool. That's all standard JavaScript and HTML, and the OL overlay element helps you for those anchored elements. Printing is actually very easy in OpenLayers because the whole map image is rendered to a canvas, so you can take this rendered image and export it as PNG graphic or as PDF. Even there are JavaScript libraries that can create JavaScript directly in the client. So for that, you would use a third-party library. But that's all possible. One more question?
Is there any opportunity for using other cartography definitions than SLD?
The question is about styling definitions, SLD, and alternatives. At Boundless or in GeoServer, SLD is supported, and the flavor of SLD that they've used, which we call YSLD because it uses the YAML format. There are also extensions to GeoServer that allow you to use CSS flavor similar to Carto CSS, but a bit different. I don't know if this is still maintained, but it's definitely available. On the OpenLayers side, currently we have style functions that you write in JavaScript. And one thing that I'm currently working on is a small separate library that allows you to turn MapBox GLJS styles into OpenLayers style functions. And something similar will probably be available for SLD, so you could use your SLD and turn that into an OpenLayers style function.
Or do you use the width of lines in the style to further drop like extra features? Like if you know that the layer is going to be turned really fat, you can drop more of them within it. Are you using that information?
I'll pass on to Dave here.
Currently, it has a fixed pixel width around the vector tile.
Is that 1 pixel or?
I think it's 14 pixels. It uses the same default one as the GeoServer streaming renderer. One of the future things I want to do is be able to make that settable for each of the symbolizers, each of the SLD styling rules. So you could have something that clips right at the edges if you want to do analysis, or something that has a very big.
I mean dropping, not clipping on the tile, but dropping features that are going to overlap other features. Okay.
No, you would have to do that at post-processing.
Okay, I think time's up because the closing session is on already. Thanks for the good questions. Thanks for the attention.